All right, continuing with Chapter 5, the topic that we're going to talk about today is called Theorems with Parallel Lines. And what we had in, remember the sections leading up to this section, we've talked about parallelograms. And then we talked about ways we can prove that quadrilaterals are parallelograms. Now here we're going to kind of incorporate that with parallel lines. Let's take a look at Theorem 5a. Make sure you copy this down in your notes. And it says if two lines are parallel, and we can tell that we have parallel lines because, by the symbol with the arrow, right? So we have two parallel lines, so they're indicating that they are parallel. If two lines are parallel, then all points on one line are equal distant from the other. And what I've shown here is we have point A up here, and then we got a point B, and we have two other points here that are shown on these two lines. And if I drew these lines so that they're perpendicular to one another, the distance from A to B, this distance, whatever that is going to be the same as this distance. So no matter where I put 2 points, and as long as I make those the line that joins them perpendicular, those distances are all going to be the same. And that kind of makes sense since the two red lines are parallel, right? Okay, Theorem 5.9. If three parallel lines cut off congruent segments on one transversal, now let's make sure we understand what's being shown. The three red lines are the parallel lines because they have the arrows through it. So they're indicating that those are parallel. So I have line AX, I have line BY, and I have line CZ, and they're parallel to one another. And if in these three parallel lines, they cut off congruent segments on one of the transversals. Now I'm going to highlight one of these transversals. So if one of these transversals, and remember a transversal is a line or a segment that cuts through parallel lines. So that's one of the transversals. Now if from A to B is the same distance, and say it's 3, I'll just put down 3, and say B to C is 3. So in other words, if that transversal, if those three parallel lines cut off congruent segments on one of the transversals, then the same thing's going to happen in the other transversal. And I'll indicate that by the yellow line here. So in other words, these are going to be of equal distance. From X to Y is the same distance as Y to Z. All right, Theorem 5.10. A line that contains the midpoint of one side of a triangle and is parallel to another side passes through the midpoint of the third side. Now this is a pretty wordy theorem. So what it's saying is the segment that they're talking about is right here. Now if that segment contains the midpoint of one of the sides of the triangle, now is M a midpoint of AB? It is, because these two parts are equal. So if I've got a segment and it contains the midpoint of one side of the triangle and that segment is parallel to another side of the triangle, then it hits the midpoint of the other side, meaning that N is the midpoint of AC, or in other words, meaning that those two parts are equal. All right, last theorem. It says the segment that joins the midpoints of two sides of a triangle. So I've got a segment here, and it's joining the midpoint of two sides of the triangle. Now how do I know M and N are midpoints? Well, because these are two equal parts and these are two equal parts. So M looks like is the midpoint and N is the midpoint of this side. Now, if I've got a segment that joins the midpoints of the two sides of the triangle, then two things happen. This segment right here has to be parallel to the third side, and it's half as long as the third side. So if this side is 10, well, the length of that segment joining the midpoints is half as long, or in other words, 5. All right, let's take a look at a few examples here on this sheet. And let's take a look down at the bottom. And it says line AP, line BQ, line CR, and line DS are parallel. Right? So we can see that they look like they're parallel. With AB equal to BC equal to CD. So notice that they've represented that with the tick marks. So this part equals this part equals this part. Now what they're going back to, or the theorem that they're using here, I'm not going to re-magnify this, I guess, but what they're trying to show here is, remember, when you have parallel lines that are crossed by a transversal, and the segments that are created are cut off into equal parts, then these are cut off into equal parts. All right, so let's take a look at number one. If QR is 3x, so QR, from Q to R is 3x. So that part is 3x. And RS is x plus 12. So this part from R to S is x plus 12. How can we figure out what x is? Well, we know that this part equals this part. So 3x equals x plus 12. And then we solve it for x. We get all the x's on one side. I can subtract x. And I get 2x equals 12. And then divide by 2, and x is equal to 6. And that's kind of where they're going with this. Now, with the rest of the problems here, they have variations of this. Let's just set up one more. Let's go to number 2. So read number 2 as I set this up. So again, we know that these parts are equal, and I know that these segments are equal. Right, number 2, if PQ is 3x minus 9, so from P to Q is 3x minus 9. And from Q to R is 2x minus 2. Well, again, this part equals this part, right? So 3x minus 9 equals 2x minus 2. And I can solve it for x then. Okay, let's go through a couple others involving some of the theorems. Let's take a look at number 8. Number 8, it says, name all the points shown that must be midpoints of the sides of a large triangle. All right, now, you're using the theorem, and I'm not going to go back to re-magnify this, but as I look at this, name all the points shown that have to be midpoints. Well, it's obvious C is a midpoint, right? Because it's right in between Y and Z, because each of these are 6. Now, if I have a segment, and say I'm looking at this segment, and a midpoint lies on that, and say that segment is parallel to another side of the triangle, and I know they are because of this arrow right there. What do you know about the point that it hits on the other side? Well, A has to be a midpoint. So A would also have to be a midpoint. B, it looks like, let's see, B, let's see, if A is a midpoint, now here I've got this segment, right? Does this hit the midpoint of this side? Yeah, we just determined that. But is this blue segment parallel to this side in order to say that B is a midpoint? The answer is no on that. All right, let's take a look at number 9. Okay, number 9, first of all, I know B is a midpoint, right? Because it's right in the middle between the 4s. How about this? How about this? It's parallel to this side. It has a midpoint on it, so what do you know about C? Well, then it's a midpoint. So that's kind of the philosophy on these problems as you use some of the theorems that we were just introduced to. Okay, let's just do one down here to introduce that last theorem. Okay, M is the midpoint of YX, and N is the midpoint of YZ. All right, now the theorem that they're using here then is if you got a segment that joins the midpoints, then two things happen. It's parallel to the third side of the triangle, and it's half as long. So let's use that on number 11. If MN is 6, how could I get YZ? Well, if MN is half as long, well then YZ would have to be 12. So that's the type of problems here with the theorems that we're working with. So this is dealing with parallel lines in working with some of the things that we've also been talking about in this chapter.